Welcome. Let's discuss how we can solve the following exponential equations. Let's take a look at example A. What we would like to do is find the value of x, but notice that x is on the exponent. And when we are trying to solve variables that are on the exponent, one strategy that we might want to consider is, would it be possible to write the left-hand side and the right-hand side using the same base? When we take a look at the expression in the right-hand side, the base of this exponential is of a value of 3. What we want to do is take a look at the left-hand side and see if we can write the value of 9 as a base of 3. Well, let's see. 3 raised to the first, that is 3. So we cannot do that. But 3 raised to the second, it is equivalent to 9. Now let's rewrite our equation. But instead of using the value of 9, we will use the expression of 3 to the second. And now that the left and the right-hand side, they both have the same base, what we can do? We can set the exponents equal to each other. And now we can solve for x. We can divide it by 4 on both sides. So we have solved this equation. Now let's take a look at example B. We're going to approach it the same way. Notice that what we're looking for, which is the variable of x, is on the exponent. Let's try to apply the same strategy. Would it be possible for us to write the left-hand side and the right-hand side using the same base? But the exponential in the right-hand side, it has a base of 5. So what we'd like to do is look at the left-hand side and see if we can rewrite it as a base of 5 as well. Well, let's look at the exponentials for 5. 5 raised to the first is 5. We cannot do that. But 5 raised to the second, that is 25. So what we can do, we can rewrite the whole equation, but instead of using the value of 25, we will use the expression of 5 to the second. And now that the left-hand side and the right-hand side, they have the same base, we can set the exponents equal to each other. And now we can solve this algebraically. Let's start by subtracting 1 to both sides. And let's divide it by 3. X is equivalent to 1/3. Now let's take a look at example C. Now notice that this scenario, it's a little bit different because the unknown of x, it is present on the left-hand side of the equation, is also on the right-hand side on the equation, but still, that is on the exponent. We can try to apply the same rule. Let's try to see if we can write them out using the same base. On the left-hand side, we can see that the base of this exponential is of a value of 4. So now let's ask ourselves one question. The value of 64, can I write it using the same base? But let's look at the exponents of 4. 4 raised to the first, well, that is 4. 4 raised to the second, well, that is 16. We cannot use that. But when we do 4 to the third, that is equal to 64, which is exactly what we were looking for. So now let's rewrite our equation. Instead of 64, let's write 4 to the third. But 64 had an exponent of x. Well, that is still the exponent of 4 to the third. All we did, we just rewrote the value of 64 as 4 to the third, but you have to keep the exponent where it was, as an exponent of 64. So it stays as an exponent of 4 to the third. And now the right-hand side, let's just bring that down. Before we move any further, here we can apply the rule for multiplication when we have exponents. We can just distribute the exponent of x with the 3, and now it becomes 3x. And now we have achieved our objective. The left-hand side, it has a base of 4, and the right-hand side also has a base of 4. What we can do? We can set the exponents equal to each other. And now we can solve this algebraically. Let's start by subtracting x to both sides. And let's divide it by 2. So now we know that the solution is when x is equivalent to 3. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.